Hello, and welcome to this demonstration of HPE Morpheus Enterprise and HKS. In this session, we're going to look at HKS and how you use it within the HPE Morpheus Enterprise platform. We will look at the capabilities of HKS, the high-level architecture, and then we'll have a demo of how you can build, manage and consume HKS clusters within HPE Morpheus Enterprise. So what is HKS? HKS stands for HPE Kubernetes Service, formerly known as Morpheus Kubernetes Service or MKS. It has been part of the Morpheus platform since version 4 released in 2019. HKS leverages the robust automation capabilities of the HPE Morpheus Enterprise platform to streamline the process of building, managing and consuming Kubernetes clusters. In essence, HKS removes the complexity of Kubernetes, enabling users to quickly provision and operate clusters at scale. HKS is only available in the HPE Morpheus Enterprise software product. Before we dive into HKS, it's important to highlight that HPE Morpheus Enterprise delivers far more in the Kubernetes space than just HKS clusters. The platform can provision public cloud-native Kubernetes services, including AKS, EKS and GKE within their respective cloud environments, provided these integrations are already in place. Through custom cluster layouts, it can be configured to deploy other third-party Kubernetes distributions, both on-premise and in public clouds. Additionally, HPE Morpheus Enterprise supports Docker server provisioning and can integrate with existing Kubernetes clusters, enabling you to brownfield pre-existing clusters and bring them under centralized management. This ensures those clusters benefit from the full suite of capabilities the platform offers. And of course, HKS is now supported on HVM, adding even greater flexibility. Now let's look at HKS in more detail. Deploying, managing and operating Kubernetes clusters is often complex and time-consuming. Fortunately, HKS dramatically simplifies these processes, streamlining the entire experience while delivering additional enterprise-grade capabilities. HKS is built around 3 core pillars designed to help teams easily build, manage and consume Kubernetes clusters at scale. And all of this can be actioned and managed via the HPE Morpheus Enterprise user interface, command line interface and API. Under the Build Capabilities pillar, HKS is deployable on any attached cloud. It can also be deployed onto bare metal servers and HVM hypervisors. MKS layout version 1.31 is CNCF certified and subsequent layouts are currently working towards certification. Cluster Layout provides the user several choices at provisioning time, from the version of Kubernetes to deploy to HA or non-HA deployments. Users can also create custom Kubernetes cluster layouts to tailor the Kubernetes deployment to their specific requirements, or even to deploy other third-party distributions such as K3s and Rancher. If a customer already has existing Kubernetes clusters, these can be easily imported into the platform and managed centrally. You can also leverage third-party integrations within the platform to automate tasks such as creating DNS records, updating CMDB entries and more. Under the Manage Capabilities pillar, HKS provides comprehensive cluster visibility for all clusters managed within the platform, presenting detailed information on the cluster such as configuration and object information, logs, performance metrics, and much more in a unified UI, dramatically simplifying operations. With HKS, you gain the ability to monitor the status and health of both the cluster and its associated elements via monitoring and logging in the user interface. You can also create, update and manage Kubernetes objects such as deployments, service accounts and storage classes without needing to memorize kubectl commands. For advanced control, kubectl commands can be executed directly from HKS, eliminating the need to switch contexts or store credentials locally. Upgrades of HKS are automated. New cluster layouts with updated Kubernetes versions are included in the HPE Morpheus Enterprise releases. To upgrade, simply select the desired layout in HKS and the platform handles the process. If you need to scale up or out your Kubernetes nodes, this is also now a simple task. To scale up, a user can select to change the plan size of a worker node. To scale out, by adding additional worker nodes, all required automation is built into HKS, and nodes can be added via the Actions menu item of the cluster. Recent updates to HKS now also include auto scale out for certain layouts. And finally, under the Consume Capabilities pillar, once a HKS cluster is deployed, you can take advantage of the extensive provisioning and automation capabilities offered by HPE Morpheus Enterprise. If you're already familiar with using Morpheus for virtual machine provisioning and automation, you'll find that many of these features seamlessly extend to HKS clusters. For deploying workloads into HKS, you have multiple options including spec templates, instance types, Kubernetes blueprints, Helm blueprints, and Morpheus blueprints. All of these can be configured as self-service catalog items, simplifying the user experience. The catalog enables you to create a curated set of application services that can be deployed on any connected cluster. Similar to VM provisioning, you can leverage phase-based automation to orchestrate the entire Kubernetes workload lifecycle from creation to teardown. Morpheus automation capabilities include tasks, workflows, script templates, and file templates, which can be applied during initial provisioning and for ongoing day 2 operations. Governance and control are enforced through roles and policies, allowing you to define user permissions, service plans, and group access. Clusters or even individual namespaces can also be shared with Morpheus subtenants for multi-tenant environments. As mentioned earlier, HKS is exclusively available on HPE Morpheus Enterprise software platform, and there are no additional costs for deploying HKS or any workloads provisioned through HKS when HKS workers are deployed on already licensed hosts such as HVM. The high-level architecture of HKS begins with the underlying platform, which can be any integrated public or private cloud environment or bare metal servers. As of version 8.0.9, HKS is also supported on HVM, adding further flexibility. On top of this platform are the servers designated for HKS, which run Ubuntu 22.04 or 24.04. When deploying HKS on an integrated cloud, the system automatically provisions and configures Ubuntu virtual machines during installation. For bare metal deployments of HKS, Ubuntu must be pre-installed. Above the OS layer sits the container orchestration layer, Kubernetes, followed by the container runtime, Containerd. Additional functionality is delivered through cluster packages including Calico for networking, FluentBit for logging, Nginx for ingress, Prometheus for monitoring, and Rook for storage. We will now look at a demo of some of the build capabilities of HKS. HKS clusters can be deployed through the HPE Morpheus Enterprise Manager User Interface API or CLI, offering a self-service model that simplifies Kubernetes provisioning and eliminates the complexity of manual installation. Using the HPE Morpheus Enterprise Manager, we navigate to Infrastructure Clusters and then select Add Cluster. Several cluster types are available and users will only see options permitted by their assigned role. Here we can see the public cloud-native Kubernetes deployments AKS, EKS and GKE, the external Kubernetes cluster type, which is used when you want to brownfield an existing Kubernetes cluster into the HPE Morpheus Enterprise Manager and manage it as if it were provisioned from the platform. To deploy a HKS cluster, we need to scroll down and select Kubernetes cluster as the cluster type. As with most provisioning actions in HPE Morpheus Enterprise, an intuitive wizard will guide us through the provisioning process. The first step is to select a group. Groups are a way to control user access to clouds, and users will only be able to select groups that are allowed by their role. In this demo, we will select the production group. Next, we need to select the cloud for the HKS cluster. In this demo, we will be provisioning HKS onto a HVM cluster that has already been provisioned into the environment, so we select the cloud that is associated with the HVM cluster. Note that groups and clouds must be configured beforehand, and for bare metal deployments of HKS you need to create a private cloud group. Next we set a name for the cluster and then a name for the resources, and then we click Next to move on to the next screen. We are now at the cluster configuration screen. First we select the desired cluster layout. In this demo we will choose the MKS Kubernetes 1.32 HA cluster on HVM layout. This will provision a Kubernetes version 1.32 cluster on HVM Ubuntu 24.04 virtual machines. The cluster will consist of 3 master nodes and 3 worker nodes. Selecting the non-HA version of this layout would provision a single master node with 3 worker nodes. Currently the layouts refer to MKS, but this will be renamed to HKS in upcoming release. If we had have wanted to provision HKS onto bare metal servers, then we would need to select one of the non-HVM layouts. When selecting a bare metal layout, you need to have the servers pre-installed with Ubuntu 24.04. So what exactly is a cluster layout? A cluster layout defines the configuration for a specific cluster deployment. For HKS, a cluster layout specifies the target where the cluster will be provisioned, the Kubernetes version to deploy, and HA versus non-HA configurations. HPE Morpheus Enterprise also gives you the flexibility to create custom cluster layouts. This means you can configure the platform to deploy virtually any third-party Kubernetes distribution. As long as the deployment can be automated using Bash or PowerShell scripts, you can build a cluster layout to handle it. Creating cluster layouts from scratch does require advanced automation expertise, both in HPE Morpheus Enterprise and in the application you are deploying. However, if you only need a small modification to an existing layout, such as replacing Calico with WeaveNet for example, you don't need to start from scratch. Simply clone an existing layout, apply your changes and save. The cloned layout will automatically appear in the list of available layouts when provisioning a cluster. Now back to our configuration. The next thing we need to set is the plan. This defines the size of the master nodes. We will leave this set to 2 CPU and 8 GB of memory. Next we have the resource pool. In a previous screen we selected to deploy the HKS cluster into the cloud that contains our HVM cluster. This cloud could contain multiple HVM clusters, so the resource pool field allows you to select the actual cluster to build the VMs on for HKS. As this is a demo, we will reduce the root volume to 40 GB, and we will also set the data store to be our GFS2 data store. A requirement of HKS is that the master node has a root disk and a data disk, so we also need to make sure that we add a second disk by clicking the plus icon to the right of the screen. We will also set this to 40 GB. Now we need to select the network to provision the HKS nodes onto. We will set this to the production network. One final thing that we need to do is to make sure that when the VMs are provisioned, we have a user account created we can use to log in with. There are numerous ways that we could do this. For example, an Ansible post-provisioning script, but in the demo we will use a simple feature in the manager that allows you to create a user account for the user that is provisioning the cluster. This setting can be found under User Config. When the checkbox for Create Your User is checked, the manager will automatically create a Linux user on the virtual machine, providing that you have defined the Linux username and password to create in your user settings. All of the other settings we can leave at their defaults, and we can click Next to proceed. We are now at the configuration screen for the worker nodes. You can see that 3 workers will be deployed. The plan, volumes and network parameters have been inherited from the previous screen, but they can be changed if desired. We will leave everything set as it is and click Next to proceed. On the automation screen, we do not need to set any automation scripts to run, as all of the automation required to install Kubernetes is configured into the cluster layout that we selected. However, as we selected the HA layout, we have the option to configure kubevip during cluster provisioning. kubevip is an open source solution that provides virtual IP management for Kubernetes clusters. It enables multiple master nodes to share a single IP address, ensuring seamless failover. If one node becomes unavailable, another automatically takes over. To enable kubevip, under the load balancers section, we select Create kubevip. We now have the choice to either specify an IP pool for the virtual IP address or provide a static IP address ourselves. In this demo, we will set the production IP pool to provide the IP address for kubevip. With kubevip configured, we click Next once more and we are now at the review screen. Everything looks fine, so we now click Complete to start the provisioning. The new cluster will appear in the list of available clusters. By clicking on the cluster name, we can monitor the progress of the install. Here we can see the cluster provisioning progress bar, which gives us a high-level overview of the provisioning process. To get more details, we can click on the History tab to view the details of each of the provisioning steps. We'll now pause the video whilst the cluster provisioning completes. Okay, so we can now see that the HKS cluster is successfully provisioned, as indicated by the green status in the top left of the screen. And under the History tab, we can see that all tasks have now completed successfully. We will now look at a demo of some of the management capabilities of HKS. When HPE Morpheus Enterprise manages a HKS cluster, whether it's provisioned from Morpheus or added as an external cluster, it automatically discovers the cluster configuration, providing full visibility through the Manager user interface. On the Cluster Infrastructures page, a dashboard at the top summarises the cluster types under management, total workloads deployed, and cluster capacity for CPU, memory and storage. Below the dashboard, we see a list of managed clusters with details such as the cluster status, meaning that it has confirmed connectivity with the manager, the number of worker nodes, and high-level metrics for compute, memory and storage. Clicking on a cluster name takes you to the cluster details page, from where you can manage many aspects of the cluster. The cluster details page provides comprehensive information about the cluster, including its configuration, resource counts, and CPU and memory performance graphs. At the top left of the page, we find the cluster's status, along with the last sync time and duration, similar to what you would see in a cloud integration. To perform a manual sync, we can click the Actions button and then select Refresh. In the centre of the cluster details page, several tabs are available for more in-depth management and configuration options. The Summary tab provides an overview of cluster configuration, including the selected cluster layout. CPU and memory graphs display per namespace usage, which is useful for troubleshooting performance issues. Under the Control tab, we have the kubectl and Packages sections. kubectl provides a handy feature which enables the execution of kubectl commands, workloads, or application of templates on the cluster. Role permissions control a user's ability to be able to perform these actions. The Packages section displays the currently installed cluster packages. The Access tab provides visibility and management of namespaces, service accounts, roles, and role bindings. Not only can we view these objects here, but we can also add new objects and even edit the spec of existing objects. Let's create a new namespace that we can use later on in our demo. We click the Add Namespace and then enter a name for our new namespace. And then click Save Changes. And that's it. Our new namespace has been created for us. Detailed information for each object can also be viewed by clicking the information icon next to the object. This will provide information on Kubernetes labels, metadata, spec, status, raw config, and events for the object. Namespaces have an additional feature in that you can also configure group access, service plan access, and tenant permissions on individual namespaces. The Nodes tab provides a list of master and worker node details and performance information. Each node can be clicked into for further information and management. The Workloads tab provides visibility and management of pods, deployments, replica sets, daemon sets, stateful sets, and jobs. We can edit the spec and view detailed information on these objects. Individual objects can also be selected to restart or delete. Jobs can also be added from within the Workloads tab. The Network tab provides visibility and management of services, endpoints, ingress, and policies. For each of these objects, we can add new objects, edit the spec, and view detailed information on the object. The Storage tab provides visibility and management of storage classes, volume claims, volumes, config maps, and secrets. For each of these objects, we can add new objects, edit the spec, and view detailed information on the object. The Containers tab provides visibility of the containers running on the cluster. We can filter the list by search or by selecting the namespace or worker node from the drop-down selection. Individual containers can be selected and then restarted or deleted. We can also view detailed information on each container. The Monitoring tab provides access to log and event information for the cluster nodes. The Cluster Actions menu item, accessed from the top right of the Cluster Details page, provides further management capabilities for the cluster. From the Actions menus, users can refresh the cluster, forcing Morpheus to perform a synchronization, view and edit cluster permissions, group, service plan, and tenant permissions, view the API token and kube config, run a workload such as a deployment, stateful set, daemon set, or job, perform an upgrade of the cluster to a new Kubernetes version, and add a worker node to the cluster. We will now look at how you can upgrade HKS. If we go back to the Summary tab, we can see the cluster layout that was used to provision the cluster. In this demo, we selected version 1.32. As part of the HPE Morpheus Enterprise release cycle, updated layouts are periodically shipped. After upgrading your appliance, these new layouts become available for both provisioning new HKS clusters and upgrading existing clusters running older layout versions. To upgrade the cluster, we simply go to the Actions menu of the cluster and select Upgrade Cluster. We then choose the Kubernetes version we want to upgrade to and click Apply. In this example, I'm going to upgrade to 1.33.9. For a high-level overview of the upgrade process, we can check the History tab on the Cluster Details page. We will pause the video whilst the upgrade completes. So you can now see that the upgrade has completed and the cluster is now reporting a green status of OK. All of the tasks, the upgrade tasks in the History tab have completed, and if we go back to the Summary tab and refresh the browser, you can see that the new version of 1.33 is reported. We will now look at how to monitor HKS cluster health in the Morpheus Manager. When managing HKS clusters, there are several areas where you can monitor and manage the health of your cluster. As we saw previously, the Cluster Details page shows the high-level status overview of the cluster health. A green OK status indicates that the cluster is operating normally. If the manager detects issues in the cluster, this will change to a yellow warning or red failed. The Nodes tab reports the health status of each node in the cluster. If an issue is observed on a particular node, the information icon can be selected to get more details, or the node itself can be clicked on to go to the details page for that particular node itself. Now let's look at how to scale worker nodes if performance requirements change. Additional worker nodes can be added via the Actions Add Worker menu item of a HKS cluster. This initiates the Create Cluster Worker screen, which takes the user through the process of adding a new worker node, similar to when deploying HKS. To scale up worker nodes, you simply reconfigure the individual worker nodes via the Actions Reconfigure menu item of each worker node. When reconfiguring a server, a new plan can be selected to provide additional CPU or memory. HKS Autoscaler was also added in version 8.0.11. Initially, only clusters created on VMware clouds using the Kubernetes 1.32 and 1.3 layouts support autoscaling. When enabled, clusters are constantly monitored and considered for scale-up when there are pending pods which can't be scheduled due to insufficient resources. Clusters are considered for scale down when nodes are underutilized and drainable. Finally, let's look at how governance and control is provided in HKS. HPE Morpheus Enterprise provides several ways that you can control what users can do on the HKS cluster. First, we have role-based access control, where there are a number of feature permissions that could be set in a user's role. You can control if they have access to the clusters section of the HPE Morpheus Enterprise, and if so, which cluster types they can provision. There is also a role permission to allow or deny the ability to execute kubectl commands and run workloads on the cluster. What a user can deploy into HKS is also governed by their role permissions. On the actual HKS cluster itself, permissions can be set for group access and tenant permissions. Group access allows you to define which groups can access a cluster. A group is also set on a user's role. So if group permissions are set on a HKS cluster, the user's role will also have to allow them access to that group in order for them to be able to access the cluster. Tenant permissions can also be set to share a HKS cluster created in the master tenant to a HPE Morpheus Enterprise subtenant. If you do not want to share the entire cluster to a subtenant, individual namespaces can also be shared instead. To do this, you edit the namespace and then you can set tenant permissions on a per namespace basis. We will now look at a demo of some of the consume capabilities in HKS. Before we look at the various ways of provisioning into HKS, let's first take a look at spec templates. It's important to understand spec templates as they form the basis of several HKS provisioning use cases. Spec templates are found under Library, Templates, Spec Templates in the Manager UI. In HKS, they provide a single place to store various YAML configurations that can then be reused across different provisioning use cases. For example, if you create a spec template for an Nginx deployment, you only need to create a single spec template which can then be reused across different provisioning scenarios. Let's look at a spec template we have created to deploy a WordPress app in HKS. The code for a spec template can be sourced from a Git repository, a URL, or added directly into the content field of the spec template itself, as is the case with this spec template. Here we can see the YAML that defines the objects that will be deployed into HKS for the WordPress application. Spec templates also support the inclusion of HPE Morpheus Enterprise variables. Now that we understand spec templates, let's explore the different ways to provision resources in HKS. If you're familiar with deploying virtual machines and applications through HPE Morpheus Enterprise, the provisioning options in HKS will feel very familiar. HKS offers several ways of provisioning, providing flexibility to meet various use cases. First, we have the Kubernetes instance type. This instance type becomes available in the instance catalog once a HKS cluster is built. It allows users to provision a HPE Morpheus instance type and select a spec template to deploy to HKS. In the demo environment, we have created a spec template called Nginx demo that contains the YAML for an Nginx deployment. To provision this to our HKS cluster, we first go to Provisioning, Instances, and then click Add. This brings up the instance catalog from which we can select the Kubernetes instance type. The Create Instance wizard then guides us through the provisioning process. First, we select the group and cloud. I've selected the production group, and the cloud here, HVM cloud, is the cloud that contains our HKS cluster. The name field contains an instance naming policy that has been configured to auto-generate instance names, but this has also been set to allow override, so I'll enter a name of our choosing. Clicking Next takes us to the Configure screen. Here we can select the namespace that we want to use. We will set this to the lab namespace that we created earlier. And finally, in the Kube spec field, we can select the spec template that we want the instance to provision. And we'll set this to Nginx demo. Click Next, and this takes us to the automation screen, which we can leave blank. And then we click Next once more, and this takes us to the review screen. We click Complete to start the provisioning. We can observe the provisioning process by clicking on the instance type to view the instance details. We'll pause the video whilst the instance provisions. You can now see that the instance is successfully provisioned as confirmed by the green status and running status reported in the top left of the screen. We can now check on our HKS cluster that the Nginx instance type has successfully deployed. If we go to Infrastructure Clusters and click on the HKS cluster that we provisioned, and the first thing we can do is if we go to the Control tab, we can run a kubectl command against the lab namespace to get pods. And you can see that this has returned the 2 pods that were deployed as part of our instance type deployment. The next thing we need to do is get the network service port. Again, we can filter on namespace, and we can see that we have a node port running on 30080. So now if we take one of the IP addresses of our worker nodes, and in a browser we browse to the IP address of the node on port 30080, this will show us the static web page for our website. To delete the instance type, all we need to do is click the checkbox next to the instance type and then go to Actions and select Delete. Alternatively, we can click into the instance type to view the instance details page and click the Delete button in the top right of the instance details page. This will delete the instance from the Morpheus manager and also delete any of the deployed objects in the HKS cluster for this instance type. The next option that we'll take a look at is the custom instance type. This is similar to the Kubernetes instance type in that the user selects it from the instance catalog, but the instance type needs to be configured from scratch. When configuring a custom instance type for Kubernetes, you attach the YAML code that you want to deploy to the configuration of the instance. A nice feature of this configuration is that you can configure a single instance type for multiple provisioning scenarios. For example, you can configure a single Nginx instance type that can provision an Nginx pod into Kubernetes or provision an Nginx VM into HVM. You also have total control over what each user is allowed to provision. One user may be allowed to provision the Kubernetes layout, and a different user may only be allowed to provision the HVM layout. Custom instance types are created via the Library Blueprints menu item in the user interface. Under the Instance Types tab, you can see an instance called Mega Nginx that reports its technology as Kubernetes. This instance type is being configured with the YAML code to deploy an Nginx deployment to HKS. Custom instance types, once created, are added to the instance catalog, so can be provisioned in exactly the same way. The only difference is that we do not need to select the spec template to deploy the YAML code, as this has been added to the instance configuration. We will now provision the Nginx custom instance type. To provision the Nginx custom instance type, we go to Provisioning Instances again, click Add, and from the instance catalog we scroll down and we click on the Mega Nginx instance type. We click Next. We'll set the group to production again. Make sure we've selected the cloud that contains the HKS cluster. I'll enter a name. And click Next. Again, I will set the resource pool to the lab namespace that we created. Click Next. Next on the automation screen, and then click Complete to initiate the provisioning. We can now click on the instance type and we can see the provisioning progress bar, and the instance type is now successfully provisioned as indicated by the green status and running. We now need to look to make sure that it is provisioned successfully in HKS, so we go back to our HKS cluster, and from the Control tab under the lab namespace we can do get pods, and we can see there's our 2 pods that have been deployed, and we can also run get services. And we can see that it is running on port 30081. If we go to our Workloads tab and we filter on the lab namespace, we can see that it's been deployed to HKS Worker 1 and Worker 3. So if we make a note of the IP address, we can copy the IP address for Worker 3 and then make a note of the port 30081. Then in a web browser we can confirm that the website displays, and this time it says this is a simple web server running in Kubernetes provisioned from a custom instance type. Finally, we will look at application blueprints. There are several different types of application blueprints available in HPE Morpheus Enterprise that enable users to deploy complex applications. For HKS, the Kubernetes and Helm type application blueprints can be utilized. Users select an application blueprint from the application catalog or via the self-service portal. As with instances, access to application blueprints is also role-based. Let's configure an application blueprint to deploy WordPress to our HKS cluster using the Kubernetes type application blueprint. First, let's take a look at the spec templates that we will add to our Kubernetes blueprint. So spec templates are under Library, Templates, Spec Templates. And if we search for WordPress, we can see the 2 spec templates that we've pre-configured that we are going to add to our blueprint. If we click the edit icon, we can see the YAML code that is contained within the spec template. The application blueprint is created via Library Blueprints App Blueprints. We've already pre-configured the Kubernetes blueprint to deploy WordPress. We will edit this blueprint and take a look at the configuration. In the blueprint configuration, we have added the WordPress logo, and then within the spec template field, we have added the 2 spec templates that we looked at previously. We will now provision the Kubernetes application blueprint. Application blueprints are provisioned via the Provisioning Apps menu item. We click Add, and this will display a list of the available blueprints allowed by our role. At the bottom, we see the Kubernetes application blueprint that we've just reviewed. We click to select it and then click Next. We can give the blueprint a name. We can choose the group that we want to use for deployment, and the resource pool allows us to select our namespace. We can click Next. The blueprint configuration loads, including the 2 spec templates. We can click Next. And then finally Complete. Our application blueprint is now being deployed to our HKS cluster. Our WordPress application is now deployed, and we can go back to our HKS cluster and run the same checks again. So on the Control tab, under the lab namespace, we will run get pods. And we can see there are 2 WordPress pods, one for the WordPress app and one for the WordPress MySQL database. We can then run get services. And we can see that the WordPress application is running on port 32177. If we go to the Workloads tab and filter on the lab namespace, we can see that the application is running on worker node 2. So we go to the Nodes tab, we can copy the IP address of worker node 2, and then put the port in 32177, and this brings us to the first page of the Kubernetes website. This now concludes the demo for HKS.